All right, in this lesson, we're going to continue to look at the volume of 3D figures, but we're going to look at some figures that have fractional dimensions, which means when we look at the dimensions, the length, the width, or the height, they might involve fractions, which just makes our calculations a little trickier. But the way we find the volume is still going to be the same. So go ahead and let's quickly take a look at the do now, because I want you to review how to work with fractions a little bit. So go ahead and turn to that page. All right, just a couple of quick comments. Remember, you need to be able to convert a mixed fraction into an improper fraction. So you multiply the denominator times the whole number, and then add the numerator. So 3 times 6 is 18, plus 2 gives me like 20, and then you keep the denominator. When you are multiplying fractions, you multiply across. You multiply the numerators, you multiply the denominators. And when you are multiplying, you can't really multiply a regular fraction by a mixed fraction. You have to first convert this to an improper fraction like we did with number 1. So I'm going to convert this. 3 times 2 is 6, plus 1 is 7. So there's my 7/3 times my 2/5, and now I can multiply across to get my product. And then just a real quick thing, whenever you're multiplying a whole number times a fraction, you can put that whole number over 1 and then multiply across. All right, just a couple of skills that will help you with the problems that we do today. So go ahead and turn to the next page, please. So one way that we've looked at volume is how many cubes can we put into a volume. And usually those cubes are unit cubes, is what we call them, where they have a dimension of 1 and 1 and 1 of whatever units we're talking about. So we've often talked about volume being the number of cubic units that we can fill a space with. Now the difference today is we're going to look at small cubes that aren't 1 by 1 by 1, but are fractional. So 1/4 by 1/4 by 1/4 in this problem. So the question that I'm asking is, if these cubes are used to build this rectangular prism, what is the volume of the larger cube? All right, I'm going to give you a minute or so to think about how you would do that, and then I'm going to come back and show you 2 different strategies and see if they match with something that you might have done. So take a couple minutes to figure out how you would come up with the volume of this larger cube, and then come back and see how you did. All right, so I think there are 2 main strategies that you can use to solve this problem. One is you could figure out the dimensions of this cube based on the size of each cube. So I know that this is 1/4, and this is 1/4, and this is 1/4. So I know the total length of this side is going to be 3/4. And the same for this side, right? It's made up of 3 cubes. Each one is 1/4. So this is going to be 3/4. And it's 3 cubes high, right? So it's also going to be 3/4. So the first strategy is to figure out cube dimensions. So let's say figure out large cube dimensions. And then to find the volume, of course, we're just going to multiply (3/4) times 3/4 times 3/4. And with multiplication, we go across. So 3 times 3 times 3 is 27. And 4 times 4 times 4 is 64. So our answer is also a fraction, and that is going to be inches cubed. All right, that's one strategy. I think another strategy is to figure out the dimensions of, the volume of one little cube, and then figure out how many of these cubes are in this space. So first of all, let's figure out the volume of this piece here. So it's 1/4 by 1/4 by 1/4. That's not so bad. Right, let's get in pen mode. Volume is going to equal 1/4 times 1/4 times 1/4. And again, we're multiplying across, so 1 times 1 times 1 is 1. 4 times 4 times 4 is 64. And then the question is, how many of these little cubes are in the large cube? And I think, we've seen this problem before. You could count, and let's think of like the top layer here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 of these small cubes up here. And you could do 3 by 3 to get that as well. And then how many of those layers? You can see we have 3 layers of 9 cubes. So there are a total of 3 times 9 is 27 of these small cubes. So if we have 27 small cubes and each one has a volume of 1/64, we just multiply this times 27 to get the full volume. So let's write what we do here. So I would say figure out the volume of the small cube and multiply by number of cubes. By number of, let's say, number of small cubes. All right, so we know that the volume of the small cube is 1/64. And we know that there are 27 of them. So you could put this over 1 if you wanted to, but I'm going to multiply across, and I'm going to get 27 over 64, and of course that's inches cubed. So you can see that we get the same answer whether we do either strategy. All right, just a recap. Strategy 1 is we use the small cubes to figure out how long the length and the width and the height were, and just multiplied length times width times height to get our volume. Or we figured out the volume of the small cube and how many of these small cubes were in the big cube, so we knew that there were 27, and each small cube had a volume of 1/64, so we were able to multiply those together to get our final volume. All right, so a little bit trickier working with the fractions, but I think you guys can handle it. So let's look at some of the problems on the next page. All right, these problems are really some basic volume problems, just that the dimensions involve fractions. Otherwise, they're pretty much the same. So number 1 is pretty straightforward. Number 2, you have a cube, so keep in mind what this number is going to mean when you're dealing with a cube. And here they're giving you the area of the base. And we talked about this a little bit in an earlier lesson as kind of a different formula for the volume. And I'm going to see if you can remember what that means. All right, so go ahead and pause the video and work on these 3 problems and come back and see how you did. All right, check out these answers. So first one was pretty straightforward. 12 times 14 times 1/2, length times width times height. And you get 168 divided by 2, but when you do that division you get 84. For number 2, this is a cube, so it has the same dimensions, length, width, and height of 3.5. I first convert that to an improper fraction like we did on the do now. So 2 times 3 is 6, plus 1 is 7 over 2. And then I find volume by multiplying all 3 sides of the cube. You get 343 divided by 8. And I turn this back into a mixed fraction by doing the division and then taking the remainder and putting it over 8. You don't have to get the decimal answer. If you're working with fractions, then your answer can be fractional as well. And then number 3, we talked about that different formula for the volume where you have the area of the base. Again, think of that area of a layer and then multiply it by the height. So this was actually the simpler version of the volume formula. So we have 72 times 15 over 2. Again, I converted this to an improper fraction. 2 times 7 is 14, plus 1 is 15 over 2. And I did the multiplication here. This one requires a little bit of more work by hand to get that answer, but when you do all that work, you do get 540 inches squared, or inches cubed, sorry. All right, turn to the next page. I have a few more problems for you to try. All right, take a look at these. These are a little bit different. This is a big storage bin, and these are some boxes in that bin. And these are cubic boxes. They have the same dimensions, length, width, and height. And the question is not asking what the volume of the storage unit is, okay? We know what those dimensions are. That'd be really easy. This question is asking, what are the dimensions of the small cubes? So you have to think about, okay, this whole side is 2 feet, but I can fit 4 cubes in there. So what would the dimensions of the cubes have to be to fit in this box? So that's a little bit tricky. And then figure out how many cubes will fit in this box. And number 5 is just a little bit tricky, just dealing with some fractions again, and question B makes you think about it a little bit differently. So go ahead and pause the video and work on 4 and 5, and then come back and see how you did. All right, let's talk about these problems. So number 4, the way you need to think about this is that in a 2-foot space, I am fitting 4 cubes. So how much would each cube have to be to fit in there? And the answer to that is 1/2. So here's a 1/2, here's a 1/2, that'll give me a 1. Here's a 1/2, there's a 1/2, that'll give me another 1, which gives me a total of 2 feet if each cube has a dimension of 1/2. These are cubes, so all the dimensions are the same, so I know it's 1/2 by 1/2 by 1/2. But you can see that it makes sense. This is also 2, and I fit 4 in, so each one would have to be 1/2. And there's enough space for 8 here in this 4-foot long length, so again, each one would have to be 1/2 to fit into a 4-foot space. So my dimensions are 1/2 by 1/2 by 1/2, and then the number of cubes, well, I have 4 cubes by 8 cubes on the bottom layer to give me 32 cubes. Then I have 4 layers of those 32 cubes. So 4 times 32 is 128 total cubes. Number 5, again, you're just finding the volume, length times width times height. So 4 times 5/4 times 8. Again, I converted the 1 1/4 to 5/4. Multiply it across, and you're going to get 40 inches cubed. And then it wants to know if the straws in the box only take up 3/4 of the volume. Well, your key word there is of. Of means to multiply. So 3/4 times the volume, total volume of 40, and that gives me 30 inches cubed. All right, one more page, I think, and of problems, and you can give those a shot. So go ahead and turn to that. All right, these next couple of problems involve some reasoning and some messy fractions. So go ahead and pause the video and work on these 2 problems, and then come back and see how you did. All right, check this out. I have a lot of work going on here. This is one of the simple formulas, right? We're given the area of the base and the height, so we have to multiply those together. I have to convert those to improper fractions first. So then I multiply those 2 together to get this, and then I convert it back to a mixed fraction, and I get 271 and 11/16. And just a little hint, this was multiple choice, so as soon as I hit that 7, I could stop technically, because this is the only answer that has a 2 and a 7 in it. I didn't really have to go through the whole thing. I could have figured out that this was where we were headed. All right, number 2. First I have to find the volume of the entire rectangular prism. So again, I have to convert these to improper fractions, multiply across, and I simplified a little bit. So you're going to get, well, let me show you what I did here actually. I did cancel the 4s. Remember, if you have a number, same number on the top and the bottom, you can cancel them. So then I multiplied across to get 957 over 8. I converted that to a mixed fraction, so that's 119 5/8. Now, I poured 87 inches cubed of red sand into the prism, which means how much space is left. Okay, so that means I need to subtract my total volume minus the volume of the red sand to see how much space is left over for the green sand. And there's my answer. All right, just one more problem. Go ahead and turn to the next page. All right, this problem is actually pretty straightforward. You have 4 boxes to choose from, but you have to find the box that has a volume of 98. So it's only one of these, so you need to do some quick volume calculations to figure out which one of these has a volume of 98. So go ahead and pause the video and figure that out. All right, I found the volume of box A, and it was 105, so that's not right. I found the volume of box B. It was close, 97.5, so not quite there. Then box C turns out to be exactly 98, so I can stop there because only one box meets the requirement, so the answer is box C. All right, so let me know if you have any questions on any of these, and otherwise you can start the homework.